In this example, we're going to be solving the equation cot theta cosec theta equals 2 cosec theta. Now the first thing to notice is that cosec theta appears in both terms. Now that might lead you to think a good idea would be to cancel those out. But the problem with doing that when solving equations is when you cancel terms, you're really dividing by that term. And in this case, you would actually end up dividing by 0, which means you would lose one of the solutions. So a better strategy is to bring both terms onto the same side and then factorize. So here we get cot theta cosec theta minus 2 cosec theta equals 0. Then we can pull cosec outside the brackets, and we'd have cot theta and minus 2. From here, we're either going to have cosec theta equals 0, or this bracket, cot theta minus 2 equals 0. Now, if we were to draw the graph of cosec theta, we would see that cosec theta equals 0 has no solutions because it's outside the range of the graph. So we're just going to state that 0 is outside the range of cosec theta, so it has no solutions. So what I've written here is the range of cosec theta goes from negative infinity up to negative 1, or you could be in 1 to positive infinity. And because 0 is not in that range, cosec theta equals 0 has no solutions. Now this is a lot of detail to go into just to say that this has got no solutions, and you wouldn't always have to do this. But if a question says fully justify your answer, this is the kind of detail that they will be expecting you to give when you justify that an equation has got no solutions. Over here we've got cot theta minus 2 equals 0, so let's go ahead and get some solutions for this bit. We'll get cot theta equals 2. Then we can take the reciprocal of both sides to get tan theta equals 1/2. To find the principal solution, we can do inverse tan of 1/2. If we do that, we get theta equals 0.464. And because our range is minus pi, to get a second solution, we can subtract pi from this first solution, and that will give us minus 2.68. Both of those given to 3 significant figures. In this example, we're going to solve the equation 2 cosec squared theta plus 5 cosec theta equals 3. So here we can see we've got a quadratic, so the first thing we're going to do is make one side 0. So we'll take the 3 over to the left-hand side. From here we can go ahead and solve this quadratic equation for cosec. This one looks like it will factorise. To start with, I'm just going to put 2 cosec theta in each bracket. And then I'm going to look for two numbers that multiply together to make a times c, which is minus 6, and two numbers that add together to make b, which is 5. So the numbers I want are going to be 6 and minus 1. So I can pop plus 6 and minus 1 in here. But obviously if I expand this out now, I would end up with 4 cosec squared theta. So I need to look for a factor of 2 to pull out of this. That's coming in this bracket here. I can divide this whole bracket by 2. And then I've got it factorised. Okay, we'll start off by solving cosec theta plus 3 equals 0. So that would give us cosec theta equals minus 3, which means that sine theta would equal negative 1/3. And if we do inverse sine of negative 1/3, we're going to get minus 0.34. To get a second solution, we can do pi minus the first solution, and that will give us 3.48. And because the minus 0.34 is not within our interval, 0 to 2 pi, we might want to look for a further solution. We can get that by doing minus 0.34 and adding 2 pi. That would get us to 5.94. So before we solve this final part, it might be a good idea to start constructing our final answer, because here we've got a solution that we don't want and we need to make sure that we don't include that. So at the bottom here, I'm going to write theta equals 3.48 and 5.94. If there are any extra solutions from this, I can just add them on there. So for the second bracket here, we've got 2 cosec theta minus 1 equals 0. Rearranging, we can get cosec theta equals 1/2. And taking the reciprocal of both sides is going to give us sine theta equals 2. Now, sine theta equals 2 has no solutions, but really we should justify why that has no solutions. So we're going to say that because 2 is outside the range of sine theta, then the equation has no solutions. And so finally, we don't have anything else to add to our solution here. So these two are our only solutions, and these are both given to 2 decimal places.